Hi everyone, so welcome back. Let's continue our discussion on integration of trigonometric function involving a trigonometric identity. So I have here a new example which is the integration of cosine 4x sine 2x dx. But this case is very different because we have two different angles. We have for cosine we have 4x, which is our alpha, and for sine we have 2x, which is, let's say this is our beta. Okay, so how are we going to transform this trigonometric function into a function that we can apply so that we can apply an integration rule? Okay, however, we have two different angles. So what trigonometric identities that would best fit on this function? Okay, so if we can recall, we have the sum and difference of two angle and trigonometric formula. We have, if you can recall, we have sine of alpha plus beta is equal to sine alpha cosine beta plus sine beta. And we have for difference of the angle, we have sine alpha minus beta is equal to sine alpha cos beta minus sine beta cos alpha. So how are we going to use these two trigonometric identities, in transforming cosine 4x sine 2x? Okay, so take note here we have actually this the same function, no? So we have here we have for alpha for cosine, and we have um, beta for sine. So therefore we have to retain this second term into our equation. So how are we going to use the second term, no, as a function for the cosine 4x sine 2x? So it is just by using elimination method. So we have to recall our algebra, diba? If we want to combine or we want to determine the unknowns of using in two equation, we can use either simultaneous equation or by elimination method. But in this case, the most useful method, no, in combining these two equation is by using an elimination method. So we combine sine alpha plus beta and sine alpha minus beta. So let's say this is our first equation and this is our second equation. So however guys, if we combine the two equation, it would probably come out that our sine beta cosine alpha would be eliminated because they have opposite sign. We have positive and negative sign. Therefore, in order to retain this term, we have to multiply both sides by negative 1, correct? So if we multiply it by negative 1, all the sign in this second equation will change into its opposite sign. Like for example, sine alpha minus beta times negative 1, it will change into negative sign. Sine alpha cosine beta, it will change into negative sign. Sine alpha beta cosine alpha will change into positive sign. So then we can finally add. Okay, so we can say sine alpha plus beta plus negative sine alpha minus beta. Then it is the same as sine alpha plus beta minus sine alpha minus beta. That is equal to, since alpha cosine beta plus negative sine alpha cosine beta is in opposite sign, therefore is equal to 0. In this case, since they have the same variable, then we can actually add its coefficient, that is 2. By further simplifying the equation, we can say that sine beta cosine alpha is equal to sine alpha plus beta minus sine alpha minus beta all over 2. And we know that our alpha is equal to 4x and beta is equal to 2x. So we can now use this new derived trigonometric identities in transforming our original function, right? So we have here our original function, which is cosine 4x sine 2x. Okay, so we use this new derived function. So we can say that it is integration of sine, what is our alpha, 4x, beta is 2x, then minus sine, our alpha is 4x minus 2x over 2 and dx. So we can now integrate, now we can divide this into two terms. Now we can say that it is sine 6x over 2 minus sine 2x over 2, so dx. So to integrate it separately, we can say that it's 1/2. I factor out 1/2, take 1/2 outside of the integral sign since it is constant. That is sine 6x dx minus the integration 1/2, then sine 2x dx. So we can now use the integration rule of trigonometric function, that is sine u du is equal to what? Is equal to negative cosine u plus c, where our u is equal to 6x and du is equal to what? 6dx. And here in the other side, we have u is equal to 2x, then du is what? 2dx. Okay? So we have here in the equation, if this is our u, so this should be our du. However, our du lacks 6, so multiply 6, and the outside of the equation multiply 1 over 6. In this case, if this is our u, then our du should be 2dx, so multiply 2. So this is now our du, then multiply 1 over 2 outside of the integration. So therefore, by further simplifying, we can say that it is 1 over 12 negative cosine 6x minus 1/4 times integration of sine 2x, that is negative cosine 2x plus c. So therefore, our final answer is 1 over 12, negative 1 over 12 cosine 6x plus 1/4 cosine 2x plus c. Okay, so this is now our integration of cosine 4x sine 2x. So this is now our